Let us start with the second part. In this session, we are going to see classifying movie reviews. In the previous session, we have seen Keras, how to set up a deep learning workstations and neural networking concepts, and also anatomy of neural networks. Let us start with this topic, classifying movie reviews. Here we have two topics. One is binary classification. Second one is multi-class classification. So binary classification is also called as two-class classification because it produces only two categories of components. Two-class classification or a binary classification may be most widely applied kind of machine learning problem. It refers to classifying the samples in one of two categories. Binary means two. In this example, we will design a neural network in order to perform two-way classification of reviews with the from IMDb Internet Movie Reviews data set to determine whether the reviews are positive or negative just based upon the text content of the reviews. For example, nowadays, many people are watching movies only based upon their rating, their star rating, or in the terms of 3.5 by 5, 1.2 by 5, 5 by 5, something like this. How these components are executed? These are executed based upon the reviews. How these reviews, huge amounts of reviews are generated from the people. We are going to concentrate on reviewing those elements by using neural networking and provides some kind of classification. Consider IMDb Internet Movie Database dataset is a binary sentiment analysis dataset consists of 50,000 reviews from IMDb labeled as a positive or negative. See, there are two categories of elements. In the case of reviews, the review may be either positive or negative. And one more point is IMDb dataset, that is 50,000, is highly polarized reviews from the Internet Movie Database. This database contains an even number of positive and negative reviews. So 50,000 reviews are available and it contains even number of positive and negative reviews. Here they are split into 25,000 reviews for the training and 25,000 reviews for testing. That means each set consists of 50% negative and 50% positive reviews. See, we are under binary classification, that is related with the movie reviews. Based upon the reviews posted in the terms of a text, we are going to generate whether it is good or not. In this case, it uses 50,000 reviews where we have 25,000 reviews are used for training. Another 25,000 reviews are used for testing. As you know, training data and test data. I told you in the case of overfit, exact fit, or something. Each set consists of 50% negative and 50% positive reviews. Why do we have two separate training and testing set? See, if you want to design a machine, the machine need to be trained. And we are going to verify how well the machine trained can be verified by using test data. You should never test a machine learning model on the same data that you used to train it just because a model performs well on its training data does not mean that it will perform well on the data it has never seen. And what you actually care about is your model performance on your new data. See, if you give enough examples for training, whenever new data came into existence for testing, it may produce incorrect output. That's why we are going to have a component, what you call both training and testing data need to be enough or maximum input need to be given. For example, we are going to have a model that end up with merely memorizing the mapping between training samples and their target, which would be completely useless for the task of predicting targets for data never seen before. See, whenever we have enough examples of training data and testing data, then only our predictions will be accurate. Just like MNIST data set, Internet Movie Database set comes packaged with the keras. I told you in the previous sessions, these are high-level components, high-level libraries. It has already been pre-processed. The reviews have been turned into sequence of integers where each integer stands for a specific word in a dictionary. So it is not at all possible for us to store entire sentences, whatever the text that are given by the people into the database. That's why what we are doing is we are going to convert whatever the information or a text into equivalent integers. The following code will load the data set. When you run it for the first time, about 80 MB of data will be downloaded to your machine. Library, keras, Internet Movie Database, that is database set, data set of number of words is equal to 10,000. Training data, training labels, test data, and test labels. That is from IMDb. I told you here in this structure, we have 10,000 samples are going to be loaded. Argument number of words is equal to 10,000, which means that we will only keep a top 10,000 most frequent occurring words in the training data. People used to have excellent, outstanding, super movie, super hit movie, blackbuster, something like this, or flop, worst movie, waste movie, something like this. So all those words, whatever the words which are commonly used, are going to be placed in the terms of 10,000. So in this case, only keep top 10,000 most frequently occurring words in the training data. Rare words will be discarded. For example, out of 10,000, for example, only two people, or out of 50,000, only two people written some word, a new word, that may be discarded. It allows us to work with the vector data of manageable size. Otherwise, if you want to consider each and every point, which is somewhat difficult task. The variables, training data, test data, or list of reviews. Each review begins with the list of word indexes. Training labels, test labels are the list of zeros and ones, where 0 stands for negative and 1 stands for positive. So totally how many data sets we have? 50,000. That should have even number of positive, even number of negative. We are dividing 50,000 examples into two parts. What are they? One part is 25,000 values are used for training data, 25,000 values are for test data. What is the main purpose of it? If we have enough training data, then only we can have proper testing so that we can produce a perfect prediction. The variables, train data, and test data are list of reviews, each review being a list of word indexes. Training labels and test labels are list of zeros and ones, where 0 stands for negative, 1 stands for positive. So it's a training data. This is integer variables like this. Since we restricted ourselves to the top 10,000 most frequent words, no word index will exceed 10,000. So here we are applying 9,999. So we have to write some code also. This is word index is a dictionary mapping words to an integer index. We reverse it, mapping integer indexes to words, decoding of these indexes offset by 3, and then here we are performing reverse indexing. For example, this film was just brilliant casting, location, scenery, story, direction. Everyone's really suited the part they played. And you could just imagine being there is a robot. Robert. It is an amazing actor, and now the same being director. So our people used to say that a photography is extraordinary. The chemistry between the hero and heroine is excellent. Sentiment is good. Music is outstanding. And taking is extraordinary, something like this. So, whatever the words we have, all those words are going to be converted into equivalent integers, preparing the data. You cannot feed the list of integers into the neural network. You have to turn your list into vectors. There are two ways for doing this. First one is padding, adding your list so that they all have the same length. Turn them into an integer tensor of shapes, for example, samples or word indexes, and then use as a first layer in your network a layer capable of handling such integer tensors. Second one is one hot encode your list into vectors of zeros and ones. This would mean that turning the sequence 3 comma 5 into 10,000 dimensional vectors that would be all zeros except indexes 3 and 5, which would be ones. What I told you, 0 is a negative, 1 is nothing but positive. So you could be using first layer in your network, a dense layer capable of handling floating point vector data. So how to prepare the data? See, based upon, we are taking only the top 10,000 values. All English sentences will be converted into integers. So in the case of integer, we have to convert all the integers into vectors. What I told you, 0 is nothing but negative review, 1 is nothing but positive review. That's it. Let us go with the latter solution and vectorize the data. We will do manually for maximum clarity. Vector sequence, there is a function that is 10,000. Create an all zero matrix shape, that is length of sequences, dimensions, results are placed, and we are producing specific indexes of results. Our vectorized training data would be X training data and test data. Vectorized sequences, training data, vectorized sequences, test data. Here, what our samples look like. What samples are? That is 1 to 10,000. 1, 1, 0, 1, 1. What is 1? Positive. What is 0? Negative. That's it. Why training data as numeric of training labels? Test data is a test labels. Now our data is ready to be fed with the neural networks. Next part, building our network. Input data is a vector and the labels are scalars. This is the easiest setup you will ever encounter. A type of network that performs well on such problem is a simple stack of fully connected layers, what you call it tensor layers, with some activation function, layer densing, units is equal to 16, activation is equal to ReLU. The argument being passed to each dense layer is a number of hidden units of the layer. What is hidden unit? In the case of neural network, we have input layer, number of hidden layers, and output layers. Output is equal to W input plus B. Having 16 hidden layers means that weight matrix W will have the shape that is input dimension 16, that is dot product with W will project the input data onto 16 dimensional representation space. That means whenever the size increases, automatically complexity is also increased. There are two key architecture decisions to be made about such a stack of dense layers. How many layers to use? How many hidden units to choose for each layer? See, I told you in the previous sessions, there is activation function, loss function, optimization. For the time being, you will have to trust us with the following architecture choice. two intermediate layers with the 16 hidden units each, and a third layer which will output scalar prediction recording sentiment of a current review. Sometimes, while reviewing some kind of reviews or writing reviews, generally people follows an approach that is reviewing previous customers information, previous people information. For example, while you are going to write some kind of review, in that case, people usually verifies the previous person's information. That is, intermediate layers will use this function as activation function, and the final layer will use sigmoid activation so as to output a probability that is score between 0 and 1, indicating how likely the samples is to have a target one, how likely reviews is to be positive. I told you one is for positive, zero is for negative. A rectified linear unit or ELU is a function meant to zero out negative values, while a sigmoid squashes arbitrary values into 0 and 1 interval, thus outputting something that can be understood as a probability. See this output. He initially input vectorized in text, everything in the terms of a sequential number of layers excess dense units is equal to 16, again dense units is equal to 16, and dense units is equal to 1. Output at the probability. Output, this is the probability. Three-layer networks. The same component can be represented in the terms of MNANIC example library, that is Keras model sequential, layer dense, units is equal to 16, activation is equal to, this is in the form of here rectified linear unit, input shape is equal to C, that is 10,000, activation, and this is 16 units, activation is equal to rectified, and then linear units is equal to 1, activation is equal to sigmoid. Lastly, we need to select a loss function and optimizer. What is loss function? Based upon your processing, we are going to produce an output. That output is going to be compared with the expected output. If there exists any kind of error, optimizer is going to change the data then to produce correct outcome. Since we are facing a binary classification problem, output of our network is a probability, so it is best to choose a binary cross entropy loss. So cross entropy is a quantity from the field of information theory which measures the distance between probability distribution, or in our cases between ground truth distribution and our prediction. Both are same. What is expected, what is actual. Here we will also monitor accuracy during training, that is model compile optimize is equal to this loss function is equal to binary cross entropy matrix is equal to C of accuracy. Sometimes you want to configure the parameters of your optimizer or pass a custom loss function or a matrix function. The former can be done by passing optimizer instance as optimizer argument. Say this optimizer, this is binary cross entropy, accuracy, and this is a compile optimizer RMS properties, loss function, cross entropy, metric accuracy. And this is validating. In order to validate our model, 20 iterations are going to be taken in the terms of X training and Y training tensors in mini batches of 512 samples. At the same time, we'll monitor loss and accuracy on 10,000 samples that we set apart. This is done by passing validation data as validation data arguments. So on CPU, it will take less than 2 seconds per iteration. Training is over in 20 seconds. At the end of every iteration, there is slight pass as a model computes its loss and accuracy on 10,000 samples of validation data. See this is a history object. It includes various parameters in order to fit the model as well as data for each metric being monitored. This history object has a plot that enables to visualize training and validation metrics by iteration. Plot of history. This is the plot. Okay. So in this case, we have how these components are going to be produced in the terms of accuracy, state-of-art approaches. Next concept, classifying newswise, a multicast classification example. Up to now, we have seen only the classification in the terms of binary. What is binary? It produces only two, either positive or negative. In general, building a network to classify readers' news reviews into 46 mutually exclusive topics. Because you have many classes, this problem is an instance of multi-class classification. And because each data point should be classified into one category, the more it is more specifically an instance of single label multi-class classification. If each data point could belonging to multiple categories, you would be facing multi-label, multi-class classification problem. Multi-class classification problem. And the reader's data set. It is a set of short newswires and their topics published by Reuters in 1986. It is a simple, widely used toy data set for text classification, but there exist 46 different topics. Some topics are more represented than others, but each topic has at least 10 examples in the training set. IMDb, Internet Movie Database, and MNIST, these dataset packaged as a part of Keras. Even in the case of movie reviews, also we have the same. From Keras, datasets import readers. As with the IMDb dataset, argument number of words is equal to 10,000. Restrict the data to 10,000 most frequently occurring words found in the data. We have 8,982 training examples and 2,246 test examples. In the case of movie reviews, that is 25,000 examples of training, 25,000 are test. Length of training data is 8,982 and the test data 2,246. As with IMDb reviews, each example is a list of integer, that is training data of 10, which consists of decode the words into this. Decode news words back to the text. Word index, get word index, and here reverse word index and dictionary of values, decode news words in the terms of join. So note that indexes are offset by 3 because 0, 1, 2 are reserved indexes for padding, start of sequence, and unknown. So these three elements are exceptional, remaining are common. That's why we have three. How to prepare? You can vectorize the data with the exact same code as in the previous examples. That is, in the case of movie reviews, it's encoding, importing of NumPy as NumPy, NP, and then to vectorize the labels, there are two possibilities. You can cast the labels list as integer tensor, or you can use one hot encoding. It is widely used format for categorical data, also called as categorical encoding. See, in the case of variables, we used to have either categorical variable or a normal variables. And then, in this case, one hot encoding of labels consists of embedding each label as L0 vector with 1 in the place of label index. Here an example definition to one hot labels dimension is equal to 46. Results one hot training labels and test labels. So building your networks. See, in the movie reviews, we created the same thing. The same thing is applied, but in the case of movie reviews, it is a binary classification. In the case of this news points, we have multi-class classification. There is a new constraint. The number of output classes has gone to 2 to 46. The dimensionality output says is also much larger. A stack of dense layer like that you have been using. Each layer can only access information present in output of previous layer. If one layer drops some information relevant to the classification problem, this information can never be recovered by later layers. Each layer can potentially become an information bottleneck. In the previous examples used 16, 16, and 1. 16-dimensional intermediate layers, but 16-dimensional space may be too limited to learn to separate 46 different classes. Such small layers may act as information bottlenecks permanently. Bottleneck is nothing but weakness, permanently dropping relevant information. For this reason, you will use larger layers. Let us go for 64 units. See this here, dense of 64 activation, that is both softmax RELU functions can be used. There are two other things you should note about this architecture. You end with the network with the dense layer of size 46, which means that it is sample. The network will output 46 dimensional vector. Each entry in this vector will encode different output class, which increases complexity. Softmax activation, you saw this pattern in MNST example. It means that network will output a probability distribution over 46 different output classes. For every input sample, the network will produce 46 dimensional output vectors. So same categorical cross entropy can be used. In this case, it measures the distance between two probability distribution between the probability distribution output by the network and true distribution of the labels. So only terminology will be changed, but exact meaning is same. Actual, expected. By minimizing the distance between two distributions, you train the network to output something as close as possible to the true labels. Model compile, optimizer, RMS prop, loss is equal to cross categorical cross entropy metric is equal to accuracy. Validating your approach. Let us set apart 10,000, 1,000 examples in the training data to use validation. Whether it is correct or not is verified. Say this is called as validation. 20 iterations are going to be trained, history, model fit, any number of iterations are 20, batch size is equal to 512, and finally display the loss and accuracy curves, plotting the training and validation, loss, import matplotlib pyplot as plt, loss is equal to so range and these values. See training and validation. This dot represent training and this line represent validation function. These are iterations. It means nothing but iterations and this is a loss. So in this case, we have the difference. You can expect one question from these two in a public examinations, very important. And you have to clearly write in a lengthy manner because movie reviews, newswide. One is binary classification, second one is multi-class classification. In the case of movie reviews, we have taken internet movie database in the terms of 50,000. Whereas newswise are concerned, number of chances, number of elements are there. In the case of binary, only positive or negative, but in this case, newswide is concerned, we have multiple number of elements. So how to validate, how to prepare the data, how to build the data, and everything. IMDb. So this is the information related with internet movie database connectivity in the terms of classifying movie reviews, that is binary classification, and you have to plot the diagram also, and classifying newswise multi-class classification. So again, all subheadings are similar to movie reviews, but only the difference exists is in the terms of outcome in between. Okay, that's all.